Hi, my name is Caleb and this is my video on the principles of structural programming. In this video we'll be covering sequence, repetition, selection and modularization and the associated programming artifacts of functions and variables and control flow. So basically the idea of sequence is we start at the top of the program and then go to the bottom, but our other things, repetition, selection and modularization, are basically the times that doesn't happen. So it's kind of like BODMAS in mathematics, where we kind of have rules for when different things happen, if that makes sense. So, things in brackets happen before, multiplication, and multiplication happens before plus and minus. So in this case, basically the thing that happens first in our program is in Pascal, is the begin and end um, keywords at the bottom of the program. So that's the bit that actually kind of runs first, if that makes sense. And in that, usually in Pascal, we call a different procedure which we use as our kind of main place where everything happens. So in this one, we're just calling main from here, and then it goes up to here, which is our procedure. So this is modularization and the idea of a black box thing. So the idea of a black box is you don't need to know how something's happening in the procedure or function. You can just know the inputs and the outputs and use the function and not have to worry about what's inside it. And that means we can reuse code between programs, and that makes our life a lot easier because we don't have to kind of reinvent the wheel. So in this case, we can just call main here, and then we don't have to worry about anything that happens inside main. It kind of stands alone by itself in that way. So the programming artifacts associated with modularization as procedures and functions. C doesn't really have procedures, they just have functions. So a procedure is a block of code that we can pass arguments to. In this case, we don't actually pass any arguments to it, we just have empty brackets. But in this more complicated program, see, this procedure here takes a variable of type display albums, which is of the type album, sorry, which is an array of album, which is a custom data type, so that's a bit more complicated. But in this case, we're passing in a string, and so we can pass data to it, and then it can operate on the data and pass us the information back, or yeah, that's basically it. So with a function, we can actually return data from the procedure, from the block of code. We don't actually just run the block of code by itself, if that makes sense. So where do we have a function here? We have most of these procedures. Here's a function. So here we're returning an integer to the, so we're returning, in this case, an integer which I think is the result from, which album we want to play, is the number associated with that. So that's basically modularization. So in this main function we have an example of selection, and that allows us to run a different block of code depending on the value of a variable. So in this case we have a string, which is just a list of numbers, a list of characters basically. It could be anything really, numbers or letters or whatever. So we ask the user to input their name. We store that name in this variable name. Then if that name equals Caleb, we run this function here, which prints awesome name to the terminal window. If the value isn't Caleb, it's Ben, then we run this block of code here, which just writes Ben is an adequate name to the terminal window. And then if neither of those is true, we have the else statement, which means it just prints whatever name it is. Let's say Bob is a silly name to the terminal window. So that's an example of selection, which allows us to, choose what variable we want, what block of code we want to run depending on the variable. And there's another way we can do that as well, which is called a case statement in Pascal, or a switch statement in C. And it's basically the same thing, but it looks a bit neater. So we've got case name of, and so we've got, if name is Caleb, we'll run this block of code. If name equals Ben, we run this block of code here. and then name equals Bob, then we run this block of code here, and if none of those are true, we run this block of code here, and it does exactly the same thing as the previous one, but it just looks a bit neater, and some people prefer it, and some people prefer if-else statements, but it kind of doesn't really make any difference in the end. So that's basically selection. Repetition allows us to run different blocks of code, a block of code so many times. So to do that, we can use a for loop. So instead of copying right line hello world 100 times, like this or whatever, that would be kind of tedious and difficult to change, and it's difficult to work with. We can actually just write for I equals, so we have to declare the integer first, and so we declare it here in the variable section. We initialize it to 1, and then for each value between 1 and 100 we write right line. So if we run that code, it does exactly that. It just writes out hello world 100 times. This is a particularly useful feature with arrays, which we'll get to in a second, but we can do it in the same way that a for loop and a case statement is the same thing. We can use a while loop, a while do loop, or a do while loop in C is another way of doing a while. Sorry, this is a pre-test loop, and it tests the value of I before the block of code runs, and we also have a post-test loop, which in C is called a do while loop, but in Pascal is called a repeat until loop. So this while do loop evaluates the condition here before the block of code runs, and this one does it after the block of code runs. Now the main difference is this one will run at least once, no matter what the value of I actually is, and that can be useful in some circumstances, but usually it's just personal preference, and they all kind of do the same thing, and you can make the main difference between a for loop and a while loop, at least in Pascal. In C it's a bit different, is you can actually increment this value here by a different, so in a for loop it increments by +1 no matter what you do. In a while do loop you can make it +5 if you want to do it, or you can minus, so you can count down, and that's gives you a bit more flexibility. But in this case the statements do exactly the same thing. Now moving on to variables. Variables is just a block of code that stores binary values. Computers don't really care for the different types of variables. That's kind of just built into programming languages to make it a bit easier for humans to understand. So we have different kinds of variables. So we have integers, which are whole numbers. We have singles and doubles in Pascal, and floats and doubles in C, and they're basically decimal places, so 2.5, 2.4, and different numbers of significant figures in each of those. You can also have strings, as I mentioned, but in C you don't have strings, you only have characters, so it's a single string, but you can make an array of characters, which is the same as a string, and that introduces the concept of array, which is really just a list of stuff with an index which we can use, and that's very useful for in using a while loop. We can go through each different value of an array and then, let's say, print it out. So we can, if we have an array of like car manufacturers, we can print out each value of the car manufacturer using the array. Where would be an example of this in our program? Can't find one currently, but we can have more complicated data types, so we can make our own custom data types. In Pascal they're called records, in C they're called structs, and we can have, so in this album record we can have 3 or 4 different, well, and any number you want, but in this case we've got 3 strings, 1 genre, which is another custom data type, and an array of tracks, which is another custom data type, so we've got an array in there. We can also actually have an array of our records, and this is all very useful for dealing with large amounts of data. So this genre is actually an enumeration, which is kind of like a constant array. We can also have constants in programming, which are basically just variables that we can use anywhere in our program, but we can't change them because we don't like global variables. You can declare global variables which can be used by any function in your program, though you don't like them because they become confusing, especially when you're using other libraries. But we're more relaxed about constants because you can't change them, so it's less confusing. And so enumeration is basically just a constant array. And I think that covers pretty much everything I wanted to get into this video, so I think that's thank you for listening.